Hi gents, I'm starting this video for method of joints. I'm on page 65, exercise 1. We're going to have a look at this problem right now. So exercise 1, they've given you two forces at the top vertically pushing down. You have two reactions. The angles in these corners of your triangle are 60 degrees, which makes them equilateral triangles. So from here, right now we have two unknown forces, pin, roller. So just the first thing you should be doing, and I wrote just 2 points here, your first one should be Bose notation. If they haven't already labelled it, you should be doing that first. So our first point here, so we can start with A, B, C, this one in the middle there, D, and then we go E, F, G. Okay, so there's our bows. We then want to check for equilibrium. So as I said before, we don't know what these are, so they're unknown, so we need to find them out first, so then we can make this truss an equilibrium. Now because we have two vertical forces and there's no angled force at the top there, we know straight away that these bottom ones here are going to be vertical forces too. There won't be an angled force at all. So it's our assumption from the start, as we said, that these forces are, I'll do this in red, these forces are pushing in this direction, okay, pushing back up as a reaction. Now if we get a positive answer like we know, those arrows will stay the same. If the answer is negative, the arrows will switch upside down. So we want to find the reactions at the supports first. Now remember with our pin can move in a couple of directions, and I'll draw this over here. So if you get a pin, it can move in a vertical or horizontal direction. And if you get a roller, it can only move in a perpendicular to the truss. So in this case, it'd be a vertical direction. So but this is really for when we do angled forces. Right now we can only go up or down. So let's find the moments, let's find the reaction. So moments around RL, okay, and we're going to state that as RL, that is RR. Okay, so moments around RL is equal to, we have one force there, so that force is pushing down, so it's a positive. 928, okay. We're saying everything's a meter, so we're going to say multiply by 1. Okay, plus, so 3 meters to get to 2,000. It's again pushing down, so 2,000 multiplied by 3. And then RR is 4 meters away, okay? So we can write in plus, going up, so it's a negative RR multiplied by 4. Okay, we're going to say that's an equilibrium once we've worked this out. So RR is a negative, so we want to put it on this side of the equal sign. So we're going to go, we can put this over here, so RR multiplied by 4, so it makes it a positive. And this one stays the same, so it'll be 928 times 1. Okay. Plus 2,000 multiplied by 3. And you should be left with RR is equal to 1,732 kilonewtons, and it's a positive, so the direction's up. So you're saying yes, keep the arrow the same. This is now worth 7,332 kilonewtons. That reaction. Now we want to find out RL, so we do that over here. So RL is equal to 928 plus 2000, take 1732. RL is then equal to 1196 kilonewtons, pushing up again. Okay, so this one here is 1196 kilonewtons. So right now, you've checked for equilibrium. So these going up and they're coming down with the reaction. So you've found there's no more unknown forces on here. So really from here then, gents, you want to start to find out the joints. Now I'm not going to do the whole truss because this video will go way too long. I'm going to find out. We want to find out this joint in here, which will allow us to find the member there, so DE and also AE. We'll find that one, and then we'll do one at the top, which will allow us to find EF and BF. Okay. From there, then you should be right to go over here and do this joint and the one at the top, and that way you can find all the other forces on those members. So we'll start with our first one. Okay, I'll just bring this up a little bit. Just fix this out. Okay, so we'll do our first one all right here. Just put a line up through there. So we want to find joint. Okay, we want to find joint, and what do we have here on this joint? We want to find A, okay, AE, and then D. So that allows us to find that bottom one and the one here on the angle. So we know we actually have a force here that we can use for that. So we'll do it like a free body diagram. So you should have a force going in this direction up, like it has. And you said that was 1196 kilonewtons, okay? And then you have, because you have that, you can place in your triangle. So your triangle has that. Now, because the arrow's at the top, the next line must be here, okay? And then you must have a line going back, because you said this is an equilibrium, okay? So, because you've added that, then you can add 1196. So you know what these arrows are going to be. So you know this one goes here, and you know this one goes in here. Okay? You can call that AE, and you can call this one ED. Okay? And you know there's 60 degrees in this corner. Okay? ED, AE. Okay? So that allows you to understand the arrow direction straight away. Now, because that arrow is pushing in, we know straight away that's under tension. That one's pushing away, so it's under compression. So if we go towards the joint, we know that's under compression, which AE is under compression. Okay, and if we go away from the joint, you know straight away it's under tension, which ED is going away, so it's under tension. Now from here, we really just want to work out what AE and ED is, and we can just use sine, cos and tan to do that. So our first one, we'll put this in, and I'm just going to go a bit further down so you can see. So we'll do tan, so we got tan angle, okay, is equal to opposite over adjacent, okay. You then want to write tan 60 is equal to, now the opposite, we know it, 1196 over ED. Okay, now remember I said, because that's on the bottom, you know it's going to be a division straight away. So ED is equal to 1196 over 1060. Okay, and then that way you know ED is worth 690.51, And as we said about ED, we already knew that was under tension, so you can write that in as tension. Okay, very important you put that into state, that you understand the direction of your force. Now from there, you know that ED is worth that. So now we might do the AE one. So AE is basically a hypotenuse, which we know. So just going to go to the blue pen. So we're going to use sine for this. So now we can go sine angle is equal to opposite over hypotenuse. Okay. And we know sine 60 is equal to 1196 over AE. Okay. Now, as we did in the last one, it's on the bottom, so it must be a division. AE is equal to 1196 over sine 60. And that way you know that AE is now worth 1381 decimal 02 kilonewtons. And we knew that was already under compression, so we need to put that in. Compression. So right now you have your two. You know that AE is worth that and ED is worth that, and they're both tension and compression, you've already stated. So we can come up to the top there and just place these in, and I might do it in a red pen. So you can say straight away that AE is worth, and you put that on there, 1381 decimal 02 kilonewtons, and the bottom one here, 690.51. Okay, just so we can start to understand what we've done. So really, we know these two members now. So from here now, gents, we want to find out EF, we want to find out BF, and that way once you've found those two, you can go ahead and then find the other side using your other forces, which you can do that. It's exactly the same as the way I'm doing it. Now, let's have a little go at our next one. So I'm going to get a new piece of paper just so you can see what we've been doing. I'm going to slide this under here. You can still see everything. Okay. Bring this across. Okay. So now we have this. We want to start to work out our next one. So our next joint, and you can write this in. So you can have joint, and you're just writing in what you have. So you got A. And we want to find A, we have B, and then we said E and F. E and F, so that's what we're finding, okay. Now for this one, we have 4. So we'll put in our first one, so we have a force going, and I'm going to change colour. We have a force going down this direction, okay, which we know is 928 kilonewtons, okay. We also have a force going up, okay, force in there, okay, which we knew was 1381.02. Now, because that force was under compression before, we know that arrow is now facing up in here. It's pushing back in. Okay, so arrows in there. What are the other two we have? Now we have two unknowns. So we have one going here, and we have another one going down here. Okay. Now with these two, because it doesn't make a triangle and there's 4, we don't actually know the arrow direction. So we take an assumption. Okay, with these two. Now I'm going to assume that both of them are under tension. Okay, I'm assuming that they're both under tension. They're both pushing away, and we'll soon find out if it's right or not. So we'll go BF, and we'll go EF. Okay. Now from here, gents, this one here, so from here we need to be doing force horizontal, force vertical, don't we? So we want to put this in at the top so it makes sense. So we got a positive, a negative, and a negative. So we always put that chart in so we can see. Now from here, that's horizontal, so it doesn't have a vertical at all. This one here has horizontal, vertical. Because there's two unknowns on a horizontal, we can't do that first. So we need to find out EF, and we need to find the force vertical of EF. So let's do that, force vertical of EF. So put in here the total of force vertical. Okay, we're going to go through and do this chart now. So what has a force vertical? So that first one does, it's pushing down, it's a negative, so it'll be negative 228. Okay. Plus, that one's pushing up, so it's a positive, so 1381 sine 60. That one there doesn't have a vertical, so we want to go straight to our EF. That's pushing negative 2, so it's negative EF. Okay, and we go sine 60 equal to 0, because this should be in equilibrium. Now, because that's a negative, we want to take that to the other side of the equal sign. So we go EF sine 60 is equal to, okay, and these just slot in, so it's 928, okay, plus 1381 sine 60, okay, and then we can just go down our list now and place this in. So your next step would be EF sine 60 over sine 60 is equal to 928 plus 1381 sine 60 over sine 60. Now you should be left with EF is equal to 267.98 over sine 60, and then you should be left with EF is equal to 309.44 kilonewtons. And because that answer is a positive, we know that that arrow is correct. Our assumption was right, so we're saying it's under tension, so we're saying that's correct. Okay, so you can place that in now. So you know that one there is now worth 309.44 kilonewtons. Okay, the arrow is showing the tension, you can put that in properly. Okay, and this is correct. Now if that answer was a negative, that's when you need to switch your arrow around. Okay, because you're saying, okay, no, it should have been under compression. Now from here, gents, we have our last one next, and we want to use force horizontal for this one because it's in a horizontal direction. So let's go ahead and work that out. Bring it back closer again. So here we go, we got force horizontal. Okay. And what do we want to put in for this one? So 928's out because it's only vertical. So this one has one. So we can go, and it's pushing in that direction, so it's a positive. So you can go 1381.02 cos 60 plus, and that one's pushing, that's positive 2. So it would be 309.44 cos 60. Okay, and then we only have one left. Plus, you can't go cos 60, it's just BF because it's already horizontal. So BF, okay, pushing there, so it's positive 2, so BF. Okay, and you can say that's equal to 0. Now from here, BF's already a positive, so we suggest we leave that on that side to make it a positive. So we go BF is equal to, that's staying positive, but these two need to switch to negatives now, don't they? So it'd be negative 1381 decimal 02 cos 60 plus negative 309.44 cos 60. Okay. Now from there, gents, it's just about going down and adding them together and working that out. So BF should be equal to negative 845 decimal 22 kilonewtons. Okay, now because that's a negative, and we said that's a tension, this should be under compression. Okay, so BF is actually under compression. So that's when we say no, that's not correct. It should actually be in here like this. Okay, should actually be under compression, and we can put our result on there, which is actually 845 decimal 22 kilonewtons. Okay, now from there, gents, that's it. You fill in your chart, which we did before. So BF is, you put that in as 845 decimal, say 22, and then you said EF was worth, put that in before, so 309, we'll just go around here, so 309.44, okay, and there you go, gents. Right, from this point now, I want you to find out the joint at the top and then the joint at the bottom, and that task will be complete.